Once again, welcome back with another vital and important class which I am going to discuss here, of your class 11 mathematics based on the concept of set theory. And dear students, all of you know in the previous class we have already discussed the introduction set theory and the types of set theory. Vividly, an entire concept has been discussed. And in this class, I am going to explain some of the important statement, vital statement, and also some problem which are most useful to you, for the different kind of exam and competitive exam which I am going to discuss here. I hope it will help you and guide you in solving the different kind of problem. And here is the concept I am going to discuss. Look at the concept. Which topic I am going to discuss here? Here is a topic, important statement that I am going to prove. Prove that the total number of subset having n elements is 2 to the power n. Understand? Another concept here which I am going to discuss here. Look at here. Two finite sets having x and y element. The total number of subset of the first set is 56 more than the total number of elements of the second set. Find the value of x and y. One of the interesting problem which I am going to explain of your class 11 mathematics. Also you can find in different kind of competitive exam. One of the interesting problem. Another concept which I am going to discuss is the cardinality of power set of power set of power set of power set of null set is equal to 16. Right? Here is another simple fundamental concept I am discussing in one class for you. How many elements of the power set of x has if the x is null set. Another simple and fundamental problem. Another interesting problem which I am going to discuss vividly for you. Yes, what is the total number of possible proper subset of a set having n elements? So these are the so many questions I am going to discuss. Most important problem. I hope it will help you. And also you will find interest in learning this problem. And these problems are mostly useful to you. Right? Let's see of your class 11 mathematics based on the concept of set theory which I am going to discuss. And do you know, students, how many subset a set has? Let's see how. The total number of subset having n elements is 2 to the power n. Understand? Total number of subset of any finite set having n element is 2 to the power n. Understand? So here I am going to discuss. This is really an interesting statement to be proved, which is mostly applicable in solving the various problems. Let's see how. Understand? So let A be finite set. Let us suppose the set A has no element. It can return as A is equal to null set because of no element. Thus the cardinality of the set A, which is n of A, is 0 because of no element. Since we know that every set is a subset of itself, so its power set of A is written as null set, including here the null set has been written including the curly bracket. And student know whatever written within the curly bracket is an element. So here phi is an element. So the power set of A has one element. So the total number of elements of the power set of A, which is n of Pa, is 1. Thus we get that when the set A has no element, it means number of element is 0. Then the total number of subset of the power set is what? 1. And we can write 1 means what? 2 to the power 0, because the value of 2 to the power 0 is 1. Thus when a set has no element, when n is equal to 0, the power set, total number of subset or the total number of element in the power set is 2 to the power 0. Right? Understand? Suppose the set has one element. Let the A be a set having element x. X is an element of the set S. So the cardinality of the set A, which is n of h1, yes or no? So its total number of subset. What are the subset are there? You are able to see these are the subset of the set A. Hence, if you write in the power set, and you know all subset can retain in the as element, and that set resulting set will be power set. So the power set of A, by taking all the subset of A, which is shown, and you can see this is the power set of the power set of A. And clearly you see when the cardinality of the set A is 1, so the cardinality of the power set is 2. And you can write 2 to the power 1, yes or no? 2. And yes, thus when a set has one element and the total number of elements in the power set or total number of subset of the set A is 2 to the power 1. Okay, understand? So similarly, let us suppose the set has two elements. Let A be a set having element x and y. So the cardinality of the set A is what? N of A is 2, right? How many elements are there? 2 elements. The total number of subset, these are the subset of the set A. How many subsets are there? There are 4 subsets. So we can write in the power set as P of A, okay, can be taken, these subsets are taken as the element and we can write the power set of A. And the cardinality of the power set of A, how many elements? If you count, okay, if you count, you see, yes, understand? So here the power set of A is 1, 2, 3, 4. So the cardinality of the power set has how many elements? 4 elements. And we can write also, yes, 4 can be written 2 to the power cardinality of the set A. And you clearly see, tell me what is the cardinality of set A? Is 2. The cardinality of the set is 2. That's why, so the number of elements of the power set and which is equal to 2 to the power cardinality of the set A. There is a relationship between the cardinality of the number of elements of the set A and its, okay, and the power of 2. You see clearly, okay, understand? So if you write which is 2 to the power 2, which is what? 4. Thus it is clear that when a set has 2 elements, and its total number of power set or it's the total number of subset of that set is 2 to the power 2. And you see clearly, you can see the number of elements of a set and here the power. Are you able to see? There is a beautiful relationship between the number of elements and the power of 2. Okay, similarly, suppose the set, so it is clear that when n is equal to 0, the total number of subset, what? 1, yes or no? Which is 2 to the power 0, right? Thus, when the set has one element, its total number of power set is 2 to the power 1, right? Similarly, okay, when a set has 3 elements, can we say the total number of subset? Or we can write the cardinality of the power of set. The cardinality of the power set of A, which is 2 to the power 3. Look at here. Here how many elements? 3 elements. Here the power of 2 is 3. Understand? So the cardinality of the power set is 2 to the power 3. Similarly, when a set has 4 elements, tell me total number of subset is the cardinality of the power of set, which is 2 to the power 4. When a set has 5 elements, its total number of subset, okay, the cardinality of the power set of A, the cardinality of the power set of A, which is 2 to the power 5. In the same process, if we continue, and when a set has R element, can you say what is the total number of subset and what is the power set of cardinality of the power set of A, which is 2 to the power R? Clearly understood? Thus, it is understood that when a set has n element, its total number of subset is the cardinality of the power set of A, which is 2 to the power n. Understand? Okay? Thus, and it is clearly understood that, okay, that number of subset of any finite sets having n elements is always 2 to the power n, and this is one of the important statement and property of any finite set. How to find out the total number of subset and how many subsets finite set has, you can clearly determine. Then it will be easy for you that what are the subsets are there. Yes, if you know the total number of subset of any finite sets, then you can find out what are the subset of any finite set of the set has. Okay, can be determined. Is one of the interesting problem for you. Okay, understand? I hope you have understood it. Let us come to the next question here. Another concept, interesting concept, which I am going to discuss. Two finite sets having x and y element. The total number of subset of the set of the first set is 56 more than the total number of element of the second set. Find the value of x and y. One of the interesting, amazing concept. Okay, based on the concept of set theory, most will find in different kind of competitive exam. Look at here. Okay, let the two finite sets be A and B. Understand? So the set A has X element and the set B has Y element. So the number of subset of the set A is 2 to the power X according to the formula, because the number of element of the set A is X. Similarly, the set B has the Y element, so the total number of subset of the set B is 2 to the power Y. Understand? Yes. But according to the question, it is given that the total number of subset of the first set is 56 more than the total number of subset of the second set. Yes or no? Yes. So using this condition, and we can use 2 to the power X minus 2 to the power Y is equal to 56. The difference between the total number of subset of the set A and B is 56. Thus, 2 to the power X minus 2 to the power Y is equal to 56. Now just to simplify and modify the statement, multiply 2 to the power Y divided 2 to the power Y in the LHS. Look at here. Okay, and here 2 to the power Y by 2 to the power Y has been multiplied to LHS. Okay, just you have to modify the statement. And 2 to the power Y whole into 2 to the power X minus 2 to the power Y divided by 2 to the power Y, which is 56 can be written 8 multiplied 7, because 8 7 is 56, right? So here 2 to the power Y whole into 2 to the power X divided by 2 to the power Y minus 2 to the power Y divided by 2 to the power Y is equal to 8 whole into 8 minus 1. 7 can be written 8 minus 1. You just modify the statement. Okay. Now 2 to the power Y whole into 2 to the power X divided by 2 to the power Y, which is, what is the formula? Can you tell me? 2 to the power X minus Y, and you can cancel here. You see the 2 to the power Y and 2 to the power Y will be cancelled. The value will be 1. Understand? Thus 2 to the power Y whole into 2 to the power X minus Y minus 1, and 8 can be written in the form of exponent 2 to the power 3 whole into 2 to the power 3 minus 1. Okay. Thus we get 2 to the power Y whole into 2 to the power X minus Y minus 1 is equal to 2 to the power 3 whole into 2 to the power 3 minus 1. Okay. Understand? And if you compare on both sides, you see here clearly, here the power of 2 is Y, here the power of 2 is what? 3. So we will compare this power. Okay. Look at here. Understand? And we can compare Y is equal to 3. Similarly, here you see, here the power of 2 is here X minus Y, and here a power is what? 2 is 3. So we will compare this one. Okay. And you see X minus Y is equal to 3. Thus Y is equal to 3 and X minus Y is equal to 3, and comparing both sides we shall get, right? And X minus Y is equal to 3. By putting the values of Y, we shall get X is equal to 3 plus 3, which is X is equal to 6. Thus we get that X is equal to 6, the value of X is equal to 6, and the value of Y is equal to 3. Understand? This is one of the interesting problem. Okay, and I hope and we will follow the question. Okay, let us come to the next problem here. Another interesting statement we are going to prove. The cardinality of the power set of null set is 16. Okay, let's see. And we know that phi set is a null set. Yes, and which does not have any element, and the number of elements of the set is what? 0. The cardinality of the phi set is 0, right? And the power set has one element. Hence, the power set of the null set P of phi is equal to phi. Okay, how many elements? One element. Again, you find the power set of phi. How many? 2 elements. Clearly understood that. And the cardinality of the power set of phi, which is 2 elements. Yes or no? Thus, the total number of subset of the cardinality of the power set of phi, which is 2 to the power n, which is 2 to the power 2, which is what? 4. Thus, the power set of the cardinality of the power set of null set is 4. Right? Understand? So, look at here. Again, the power set. Thus, we get that if you write the power set of the power set, you see P of phi. What are the elements are there? 4 elements are there. Yes, and hence the cardinality is what? 4. Thus, it is clearly understood that the cardinality of the power set of phi set is 4. Understood? Yes. Okay. Again, you see. Again, you would find out the power set of this set. Let us. Okay. And because this is the Understand? The cardinal of this set is 4, and again you can find out what is the total number of subset of this. Okay, and power set of 5. We can write 2 to the power n, because the number of element is what? How many elements are there? 4 elements. So the total number of subset of the power set of null set, which is 2 to the power n as per the formula, and here the value of n is what? 4. Okay, and by putting the value we shall get 2 to the power 4, which is 16. One of the interesting problem. Thus we get that the cardinality of the power set is of the null set equal to 16. Most of the interesting problem it is, and you will find the different kind of competitive exam. Okay, is it clear all of you? I hope you will understand, and is a question I am giving you. Okay, and this question you have to try. Yes, look at this, the question here. So I hope, and you will answer this question, and you will send me to me in my description box. Okay, let's see. I hope, and you can do this problem. Understand? Once again have a look, right, and try for yourself. Understand? Okay. Let us have another problem. Simple and fundamental problem. Same problem we discuss. What is the total number of possible proper subset of a set having n elements? It is one of the interesting problem. How many total number of possible proper subset you have to find out of any finite set? Yes? Understand? So the total number of possible proper subset of any finite sets having n elements is 2 to the power n minus 1. Note down this formula. Yes, the total number of possible proper subset of any finite sets having n element is 2 to the power n minus 1. Understand? Okay. So let's see how. Suppose the set has 3 elements. So its proper subset. What are the proper subset? Here the proper set of the set of A, we can write all the proper subset. We know all the subset of all the subset. Let's write what are the proper subset. You see here the proper subset are, okay, how many proper, so what are the elements? What are the elements are there, and how many elements are there? It is clearly understood. You can see clearly, okay, in the box, in the screen. Look at here. How many proper subset are there? Here 1, 2, 3, 4, 5, 6, 7. How many proper subset? It has 7 subset. It means if the set A has 3 elements, it has 7 proper subset. Total number of proper subset what? 7. Understand? So in proper, and all of you know the proper subset. Okay, you see, while you are finding the sets, total number of subset how many? 2 to the power n, which should be 8 here, and all subset are here. Only the set A is not here. While you are calculating the total number of proper subset, remember the student, the set A should not be taken as a proper subset, because any set is not a proper subset of itself. This is one of the vital definition of the proper subset. Any set is not a proper subset of itself. So the total number of possible proper subset is equal to n of A, which is 7. Understand? Okay, here is written is the proper subset. The set A cannot be the proper subset of itself. This is one of the definition and fundamental definition of the proper subset. Any set cannot be the proper subset of itself. That's why while you are finding the proper subset, and there are 7 proper subset you have taken, the set A has not been taken as a proper subset. So the total number of proper subset of A is n of A 7. And you can write 7 is equal to 8 minus 1, yes or no? And 8 can be written 2 cube minus 1. And you clearly see, here you see, how many elements you see here. The set has 3 elements, and you see the power of 2 is also 3. And difference minus 1. Minus 1 means we have to exclude the set A as a proper subset. That's why you have to do minus 1. Thus the total number of proper subset of the set A, which is n of A, which is 2 to the power 3 minus 1. If you take in place of 3 is n generally, so you can derive the general formula. The total number of proper subset is 2 to the power n minus 1. Is it clear? Understand? And similarly, you can find out the total number of proper subset of any set using having n elements is 2 to the power n minus 1. This is one of the interesting and problem, and also it will you can get it in different kind of exam. So this formula try to remember, understand and use it, and whenever we are facing such kind of problem. Okay, understand? So let's see is another fundamental problem. Okay, I am discussing how many elements the power set of X has if X is an null set. Already know a null set means what? Okay, no element. And we know that if a set with n element, then total number of cardinality of set is n. Yes? Yes or no? We know that if a set with n elements, then the cardinality of the set is n, and its the cardinality of the power set is 2 to the power n. Already discussed in the question number 1, first problem, first statement we prove. Yes? And here given that X is a null set, it does not mean it has no element. So the cardinality of the set X is n is equal to 0 because it has no element, and the cardinality of power set using the formula 2 to the power n, simply just in place of n you write 0. Yes, so 2 to the power 0 is what? 1. Thus the total number of power set, yes, the cardinality of the power set is 1. Hence okay, the power set of X has one element. Understand? Okay, this is just a simple problem based on the using the formula. Okay, 2 to the power n. The total number of proper subset of set is 2 to the power n. Okay, so how you see the formula can be useful in solving, in finding the total number of subset, okay, of a given set, or you can find out the cardinality, the power set of A. Yes, understand? So the power set of A is Px has one element. Understand? So these are the most vital problem. Okay, here I have discussed vividly for you. I hope and you will follow the class. Yes, and also practice the similar kind of problem. Okay, here is an assignment for you. Look at the assignment. Simple concept based on the concept of subset, which you already know, and you can do it. Okay, so it is my great pleasure to explain such kind of problem to you. I hope you will follow the class. Okay, thank you for your interest and eagerness for the class. I hope the class will be most beneficial to you. Yes, once again, thank you for your interest and eagerness for the class. Thank you, student.